oops, I forgot to write limit as delta x approaches 0 of this divided by delta x. So I just distributed out the delta x from the numerator here. So it gets to 6x plus 3 delta x. And then I can cancel those to get the limit as delta x approaches 0 of 6x plus 3 delta x. And then I can substitute delta x in now. So 6x plus 3 times, it says it approaches 0, so 3 times 0 equals 6x. And that is the answer. That is the derivative function of 3x squared plus 1. So this was our original up here. And f prime of x equals 6x. Okay, so we just found the derivative function. And to find points now, to find like the slope at specific points on f of x, we could say f prime of 0. You know, find the slope at 0. 6 times 0 equals 0. F prime of 4. 6 times 4 equals, this is my f prime of x function now. I can just use this to find slopes on that original function graph. So 6 times 4 is 24. F prime of negative 2 is 6 times negative 2. So the slope on this graph at negative 2, of x value of negative 2, would be negative 12. And I can also just graph this derivative graph now. It's 6x. So, 6x. That's what the derivative graph looks like if this was 6, 1, 12, 2, did that quickly. But now I have the derivative graph just by solving for it, not even drawing it, right? So this is very exciting. Here, I'll do one more example for you. Given f of x equals x squared plus 2x plus 1, find the derivative function for f of x and f prime of 3. So find the slope at a value of 3. And we're going to find the function first and then the specific point, because as you saw in the last example, it was really easy to find the slope at a specific point once we have the general derivative function. So to do this, it's going to be just like the last problem. We're going to use the definition of the derivative by limits, and then we're going to simplify it until we get a single function down. Okay, so the limit as delta x approaches 0 of f of x plus delta x. That means we substitute all the x's here. We put x plus delta x is there. So x plus delta x squared plus 2 times x plus delta x plus 1. I'm going to put that in brackets. Minus f of x squared plus 2x plus 1 divided by delta x. And then I'm going to FOIL this and then simplify. So in a few steps, I'm just going to do the math. X squared plus 2x delta x. This will probably be the hardest part of the actual algebra for calculus, at least in the beginning. So don't worry about that. It doesn't get harder algebra-wise. You just have to keep track of all of this. It gets big and scary, I know. But it'll get better once we start learning our rules. So it looks like I can cancel these x squareds. Oh, these should be minuses because the minus sign distributes. I can cancel a negative 2x with positive 2x. I can cancel a positive 1 with a negative 1. And I think that's it. So then I get 2x delta x plus delta x squared plus 2 delta x divided by delta x. I can simplify that to take out a delta x. 2x plus delta x plus 2 divided by delta x. Cancel these delta x's. limit as delta x approaches 0 of 2x plus delta x plus 2. Alright, now we can substitute the 0 for delta x. So 2x plus 0 plus 2. That means we get 2x plus 2 as our answer for f prime of x. That means the derivative function of x squared plus 2x plus 1 is 2x plus 2. And you may start to notice, like if you did enough problems finding derivatives this way, you're going to notice some patterns. You know, like if we take our last answer, 3x squared plus 1 equals 6x. Okay, and then x squared plus 2x plus 1 is 2x plus 2. I'll tell you there's some kind of relationship between the coefficient and exponent on here and the answer down here. We'll talk about that next lesson. It's called the power rule, and it will make calculus way easier. Okay, so given f prime of x equals 2x plus 2, now we need to find f prime of 3. Well, that's super easy. We just substitute 3 into f prime of x, I'm sorry. So that's 6 plus 2, which is 8. So 8 is our value for f prime of 3. So a couple more comments before we finish up here with the limit definition of the derivative. I want to tell you a couple more notations for the derivative. There's a lot more than just f prime of x. There's other ways you can say it. So another way to say it, which is kind of a lazier way, but people use it a lot, is y prime. So, you know, that'd be the y value prime. You could also, like, you're going to get u prime and v prime and a prime. That just means the derivative of that. So, you know, if y equals 2x, just a line of 2x, y prime would equal 2. Okay, so this just means the derivative. Similarly, like the equivalent would be f of x equals 2x, and f prime of x would equal 2. We're just taking out the parentheses x. Okay, I could say f equals 2x and f prime equals 2. So that one's pretty easy. And the second way of writing it, which is my personal favorite way, well, I don't know, favorite way, is that kind of weird? I don't know. Because it makes sense with the definition of the derivative using limits. So we took our definition, this thing here, by using concepts of slopes and limits. So in slope is in a line is equal to delta y divided by delta x. That's our definition, our algebra 1 definition for slope. But in calculus, we say the limit as, you know, delta x approaches 0. So in calculus, instead of using the triangles for delta, here, I'll even put all our ways of notating it here. The derivative, f prime of x or y prime, same thing, just different notation, is, in calculus terms, we call it dy over dx. So delta y over delta x and dy over dx, they mean pretty much the same thing. It's just that dy and dx are conceptually infinitesimally small. That's a hard word to say. Infinitesimally small, okay? So it's delta just on the calculus level, you know, really tiny delta is dy and then dx. So it's just rewriting delta y, delta x in calculus scale, you could say. So this notation eventually becomes the most useful later on in calculus. So in like practice problems and in future lessons, I'll be using any of these three ways of notating the derivative.